We are moving on to when we have parallel lines that intersect Yes.
Can you please tell Luke the rest were for adding Eagles on the Super Bowl and just
I didn't think there was too many. But I kind of level.
There were so many bad calls on the Eagles, and they still won.
Yeah, I mean,
Okay, we'll talk about this later, I promise. Okay.
No, that is.
Let's write down our first definition.
That one touchdown should have counted. He was out of bounds in the back of the end zone.
He had 2 feet in. You're stupid.
He was bouncing, but he did not have full control.
Alright. Kristen.
Yeah.
Across the plane.
Tristan salty, just excuse me.
If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into proportional parts. So what does that mean? So you guys see how DE is parallel to BC? Remember that's what those arrows mean? Then what that is saying is we could write a proportion that is equal. So I could say BD over DA is equal to BE over EC. So you can write a proportion if we have parallel lines in your triangle. And then the converse is also true. We can show that lines are parallel if our proportions are equal. So let's just try the first part. So the first few examples are just, can we set up the right proportion? So do we see how we have a triangle and then we have a parallel line that intersects the triangle? Okay. So when you write your proportion, you can do it a bunch of different ways. You just have to make sure your order is the same. Does anyone want to give it a shot? What our proportion could be?
6.
How about we just write the numbers up as they are, but I know what you're doing. So 12 over 14. So I went that one over this one. So now when I come back on my bottom, I have to go the same way. So then I would have to write 15 over x. And now we can just cross multiply. Solve for x. 14 times 15 is what, folks? 210. We divide out x equals 17.5. That works. Okay, on the second one, can I find this missing piece right here?
Yeah.
What is it? 10. All right, who wants to give me the proportion? Anyone? 10 over 45 equals x over 36. That's a good proportion. Cross multiply. 360 equals 45x. X equals 8. So again, if you have a line that's parallel to one side of your triangle, it makes your sides proportional. Now let's see if we can do the converse. This time we are asked, is MN parallel to JL? So we're going to write the proportion, and then we have to see if they're equal. So what's the proportion I can write on this first example? 4 over 15 equals 5 over 18. That's good. Five times 15 is 75. 4 times 18 is 72. Are those equal?
No.
So are my lines parallel? No. All right, what's JM here? $30. What's a proportion I can write now? 30 over 37.5. 30 times 30 is 900. 24 times 37.5 is. So are my lines parallel? Yes. All right, now we're given a picture where I have three pairs, three sets of parallel lines that intersect two transversals, and the same thing holds. Those lines create proportional parts, so we can set up a proportion to find missing lengths. And again, when you write your proportion, you just have to make sure you match your parts with what you wrote for the first one. You can write it really in any way you want. It's kind of your choice. Okay, so if we look at this first one, can I find this missing chunk of this bottom line? What is it? 14? Now, can I set up a proportion to find the value of x? Anyone have an idea?
14 over 15.
Yep. That works. You could have went top, bottom. You could have went x over 14 equals 27 over 18. There's a bunch of different variations that you can do.
Doesn't really matter.
Nope. Nope, it doesn't matter as long as your order is the same when you write the second part of your proportion.
So like you could do x over 18 equals 27.
That's the only way you can. You can't crisscross like that. So we're going to get 18x equals 14 times 27. And then we divide out. You guys want to try this one on your own? See how it goes? The next one. Just remember to distribute. Anyone want to go to the board? move on. Yeah, the one where we'll talk today. You take 21 times 32, right? Distribute. So you got 21.
Oh yeah, sorry, I did that online. Somebody. Yeah, thank you.
There you go. You all did 13?
Yeah.
Yep.
Good answer. Is it 9? Okay, one last definition, folks. And it is the mid-segment of a triangle. And it's just like the mid-segment of a trapezoid. The segment that connects the two midpoints of opposite sides of your triangle. So our example in this picture here would be DE, is our mid-segment. And there are two properties that a mid-segment has. It is parallel to the third side, so the side that it doesn't touch, parallel to. And it's half the length of the side it does not touch. So in our diagram here, DE would be parallel to AC, and DE would be half the length of AC. Alright, so let's try this example here. Let's just label everything they give us, okay? So we're given our triangle, and we're told that PR is 46. PQ is 40. And LN is 17. And we're also told that L, M, and N are all midpoints of those sides. So then what do I know about all three of these little segments inside here? They're all the mid segments, right? So if I wanted to find the measure of LM, how could I find this? Yeah, it's half of 46, because do you guys see how they're the parallel side? So I know that LM is half of 46. Which is
23.
23. So, what about MN?
17.
What side is MN parallel to? QP,
Yes.
so half of 40. Are we going to find QR? Double what?
17.
Yep. 30. 4. And then MR. Half of 34, which is?
17.
Yeah. Only if it's a mid-segment. So if it connects two midpoints. Alright, how are we gonna figure out what x is here, folks? Do I know anything special?
It is half.
What is half?
7x is half.
4.5x.
Yep.
No,
7x is 1/2 of 7 inches.
Yep. So you can either have a decimal or multiply out. I lied, it's the other way.
Yeah, yeah.
There we go. I'm gonna multiply both sides by 2.
14.
Bring over my 17x. Then we find x is 6.